Why is reactive power important in AC circuits? Imagine a world where electrical devices like transformers and motors suddenly stop working. That's because reactive power plays a hidden but vital role in keeping everything running smoothly. When you think about alternating current circuits, most people focus on the flow of active power, which does the actual work. But reactive power is just as important, even though it doesn't directly power devices. It helps create the magnetic and electric fields needed for many electrical components to operate. Without reactive power, devices like motors and transformers wouldn't be able to generate the magnetic fields they need to function properly. For example, transformers need reactive power to magnetize their cores and induce voltage in the secondary windings. Motors need it to produce the rotating magnetic fields that make them turn. Reactive power also helps keep the voltage levels stable across the entire electrical system. If there isn't enough reactive power, voltage can drop, causing equipment to malfunction or even leading to blackouts. Think of reactive power as the support system that keeps the voltage steady, much like how a foundation supports a building. When designing electrical systems, engineers need to consider reactive power because it affects how much current flows in the system. The total current, called apparent power, combines both active and reactive power. Even though reactive power doesn't do any work, it still makes the conductors, transformers, and generators handle more current. This means they must be sized to handle the full apparent power, which can influence the cost and size of electrical infrastructure. Reactive power also impacts the power factor, which measures how efficiently electrical power is used. A high level of reactive power lowers the power factor, meaning more current is needed for the same amount of useful work. This increases energy losses and reduces overall system efficiency. To improve this, engineers use devices like capacitors or synchronous condensers to manage reactive power, boosting the power factor and reducing waste. So, in simple terms, reactive power is essential because it supports the magnetic fields that keep many electrical devices running, maintains voltage stability, influences system design, and helps improve efficiency. Managing reactive power properly ensures our electrical systems stay reliable, efficient, and safe for everyday use.